Hello students, today we are going to study one of the most important topic of organic chemistry, namely inductive effect and resonance effect. These concepts form the foundation of the general organic chemistry which help us to understand acidity, basicity, stability of intermediate and reaction mechanism. So let's start with the simple question, which is more acidic, acetic acid or ethanol? Many students know that acetic acid is more acidic than ethanol. But have you ever wondered why? To know this answer, we have to understand inductive effect and resonance effect. So let's start with inductive effect. Inductive effect is generally effect of sigma bond. Inductive effect is generally effect of sigma bond. It arises due to the difference in electronegativity. Inductive effect arises due to difference in electronegativity. Inductive effect is a comparative effect. Inductive effect is distance depending, as regularly inductive effect decreases with increasing distance. So inductive effect is depends on distance. Decrease with increase with difference. Distance means it is inversely proportional to distance. The most important point is inductive. There is no inductive effect between the same atom and the carbon and hydrogen. So there is no inductive effect between same atom and carbon and hydrogen. Means between C and C there is no inductive effect. Between CH3 and CH3 there is no inductive effect. In CH3OH there is inductive effect. Move forward. There are two types of inductive effect, plus I effect and minus I effect. In minus I effect, generally electron withdrawing group shows minus I effect. In these groups pulls electron density towards themselves. As I told that inductive effect is a comparative effect, let's see the order of minus I effect. So the order of minus I effect is OF2 plus OR2 plus OH2 plus NF3 plus NR3 plus NH3 plus NO2 cyanide, aldehyde, ketone, acid, ester, halogen, fluorine, chlorine, bromine, iodine, OR, OH, alkyne, phenyl, alkene and hydrogen. Next we see plus I effect. Generally electron donating groups show plus I effect. Groups push electron density towards the carbon chain. The order of plus I effect is CH2 minus, NH2 minus, O minus, tertiary carbon, secondary carbon, primary carbon, CH3. helium, deuterium, and hydrogen. So these are the order of minus I effect and plus I effect. Now let's take one example to find the acidity. Which is more acidic? CH3COOH and ClCH2COOH. Which is more acidic? So, in this, chlorine is highly electronegative in nature. It exerts minus I effect, so it pulls electron density towards themselves. So, hydrogen can easily release. So, we can say that ClCH2COH is more acidic due to minus I effect. Now, let's learn resonance effect. In resonance effect, there is a delocalization of pi electron and lone pair within the molecule. So, in resonance effect, there is delocalization of pi electron and lone pairs. Unlike inductive effect, in resonance effect, there is inverse of pi bond and lone pair. In acetic acid, there is, when it releases H plus, acetate ion form. Right? This acetate ion can be represented in a two resonance structure like COO minus and CO. This negative charge is not localized only on one oxygen atom. It is distributed over the both oxygen atoms. So this acetate ion is stabilized due to the resonance stabilized structure. So due to this resonance stabilized structure, it releases H plus very easily. Now let's come to our original question, that why acetic acid is more acidic than ethanol. In ethanol case, when ethanol releases H plus, ethoxide ion form. This ethoxide ion is not stabilized by resonance. This negative ion is only localized only on this one oxygen atom. So it is less stable. So this ethoxide ion is less stable, while this acetate ion is more stable. So the students, the acidity of acetic acid is mainly due to the resonance stabilized structure of acetate ion. Thus, resonance effect and inductive effect work together to make the acetic acid much more acidic than ethanol. So the final summary is, inductive effect is a displacement of electron through sigma bond, while in resonance involves delocalization of pi electron. Electron withdrawing group show minus I effect, while electron donating group show plus I effect. So let's solve the final question of this class. Orange, give the order of acidity. CH3COOH, ClCH2COOH, Cl3CCOOH. Pause the video and think about it. In CCl3COOH, there is a more number of chlorine group. It means chlorine shows minus I effect. So more minus I effects, that's why CCl3COOH showing more acidity. So the order of this. I hope you understand this concept very well. Thank you.